Today, Tonga's volcanic eruption is unlikely to cool Earth, study confirms. The eruption of the Hunga Tonga volcano that rocked the South Pacific Ocean in January won't affect Earth's climate despite sending ash clouds tens of miles high into the atmosphere, a new study confirms. Strong volcanic eruptions, such as the one that ripped apart the uninhabited Polynesian islands of Hunga Tonga-Hunga Ha'apai on January 15, sometimes cause short-term cooling of the planet. But this would not have happened in the recent mega-eruption, despite the fact that it spewed volcanic ash to a record height of more than 25 miles, 40 kilometers. The new study confirms previous estimates, stating that the cooling effect of Hunga Tonga could range from just 0.014 degrees Fahrenheit, 0.004 degrees Celsius, in the northern hemisphere and up to 0.018 degrees Fahrenheit, 0.01 degrees Celsius, in the southern hemisphere, which is even less than a few the expected previous estimate. How much a volcanic eruption cools the climate depends on the amount of sulfur dioxide in the volcanic clouds it produces. Sulfur dioxide in the atmosphere forms aerosol particles, which bend sunlight, thereby reducing the amount of energy entering the Earth's system. For example, the 1991 explosive eruption of Mount Pinatubo in the Philippines resulted in a cooling of about 1.1 degrees Fahrenheit, 0.6 degrees Celsius, that lasted for nearly 2 years. But the ash spewed into the air by Mount Pinatubo contains about 50 times more sulfur dioxide than the clouds produced by Hunga Tonga. The new analysis looks in detail at the spatial distribution of volcanic aerosols in the atmosphere and the effect of volcano location on concentrations. Southern Hemisphere volcanic eruption emissions are mostly confined to circulation in the same hemisphere in the tropics, Tianjun Zhou, a researcher at the Institute of Atmospheric Physics at the Chinese Academy of Sciences, said in a statement. With less impact in the northern hemisphere. This in turn causes weaker global cooling than occurs in the northern hemisphere and tropical volcanoes. However, the researchers caution that this is an interim assessment based on new modeling that takes into account the latitude at which sulfate aerosols are released. A further challenge to modeling this is the uneven historical data, as several southern volcanic eruptions of the same magnitude exist in the historical record. In the model, the researchers used 70 selected volcanic eruptions over the past millennium and tracked the global average surface temperature response for the 1-year period following the eruption. They also double-checked their analysis of 6 large, well-documented tropical eruptions, such as 1991's Mount Pinatubo, to see if their predictions matched reality, and found that the model worked in that case.